we're going to look at the inverse trig functions. So let's create them. So first of all, inverse sine. So the notation for inverse sine is the -1. Now, this explains why we have the reciprocal ratios. So we don't get confused and think the power is -1. You never have negative indices when it comes to trig. They're always positive. We use the reciprocal ratio if we want 1 over. So it comes from the sine function, obviously. So let's just redraw our sine function. The domain, or real x. Range, -1 to 1. However, no inverse, fails the horizontal. We want to get a piece of this curve, which will get as much of the range as we possibly can. So we want to get a piece. The piece I'm going to choose is between -pi and 2 to pi and 2. It'll get 0, which we want. It'll get positives, which we want. It will get the whole of the range, which we want. So our range remains at -1 to 1. So our new curve, inverse sine of x, will have a domain between -1 and 1. And we'll have a range -pi and 2 and pi and 2. And this explains why, when you're using your calculator to find angles, it doesn't give you obtuse angles. It'll give you a negative acute angle when you're doing it. Because it's using the function, the inverse sine function. So it can only give you answers between -90 and 90. So let's draw it. Bit hard to do it on that particular one because of the scale. I mean, there's 1 and there's pi over there. So I'll just draw it separately. Now, what you're basically talking about is a sine curve. So there we go. But it's winding down the y-axis instead. So it's just a little piece of that. So there's y equals the inverse sine of x. All right, let's look at cos. So the original graph, y equals cos x. Again, no inverse. I want to get a piece of this one. Now, I can't go -pi and 2 to pi and 2 this time, because that would fail the horizontal. So this time, I'll grab between 0 and pi, and again, we'll get the whole range when I choose that. So inverse cos, domain, -1 to 1, range, 0 to pi. That's why when you use cosine on your calculator, it does give you obtuse angles. It can only give you answers between 0 and 180, or 0 and pi. So when we draw that one up, again, a bit hard to do it on that because of the scale, so let's just redraw it downstairs there. And we've got our cosine graph. There, a little piece of it. So there's y equals inverse cos of x. Let's do tan. Y equals tan x. Domain. This is the interesting one. Of course, we've got all those asymptotes. All x except x can't equal pi and 2 plus or minus pi k. I suppose I didn't need plus or minus pi k there, do I? Because I was saying k is an integer, and integers can be negative. So we could just have plus pi k. But anyway. Fails the horizontal, but fairly easy to pick with this one because of all the asymptotes. We just got to pick between 2 asymptotes. So I'll pick the obvious one. Minus pi and 2, pi and 2. And so again, when you use tan on your calculator, you'll only get answers in between 90 and -90. So it won't give you an obtuse one. And let's draw the sideways one. Come on. There we go. There's inverse tan. Okay. Now, some rules then, how we can play with it. Have a look back at the picture. Inverse sine, odd or even, rotational symmetry. So therefore, function negative x is equal to the negative of function x. So inverse sine of negative x, that's an odd function. Cosine, odd or even? No. But if you were to shift it pi on 2, you could create an odd function.
Right.
And so that's where this relationship comes up with the pi minus inverse cos. So you got an odd function shifted up pi on 2. And tan, well, tan's a bit easier because again it's just a straight odd function if you look at the picture. So inverse tan negative x is the negative inverse tan x. One other relationship, the inverse sine of x plus the inverse cos of x will always equal pi on 2. Angle sum of a triangle. Find the exact value without using calculators.
Oh.
We're talking about an angle. So we're saying which angle is root 3? It's one of our exact ones.
Pi on 3.
Pi on 3 minus
Pi on 4.
equals
Pi on 12.
inverse sine of 1 on root 2
Pi on 4.
minus the inverse sine of minus a half.
Pi on negative plus pi on 6.
They end up being plus. Because remember, inverse sine will only give you an answer which is either acute or minus acute. So the inverse sine of minus half is minus pi on 6, but then we've got minus becomes, and we get 5 pi on 12 as our final answer. Cosine of the inverse sine of 40 on 41. Remember, inverse sine is an angle. So we're finding the cosine of this angle. You don't need to go to your calculators.
Draw a triangle.
Exactly. Let's have a look at it. There's our triangle. Let's say that angle there is the inverse sine of 40 on 41. Well, that would make the opposite side 40, hypotenuse 41, other side's 9. We're now basically saying is, what's the cosine of that angle? Oh, well, it's 9 on 41. Okay, let's do it the other way around. Inverse sine of the sine of 5 pi on 6. Now, the biggest mistake here is to give the answer 5 pi on 6. Because you think the two is going to cancel. But they don't, because inverse sine can only give me answers that are acute or negative acute. So, sine 5 pi on 6, would that be positive or negative?
Positive.
Therefore, it's the positive acute angle I'm looking for. Pi on 6. So you've got to be really careful with those ones. Remember, you're talking about a function. We've restricted the domain, which means for the inverse function, it's restricted the sort of answers we can get. Sine of 2 times the inverse cos of 3/5. But remember, inverse cos 3/5 is an angle. So all we're saying is sine 2 theta. Okay? So if theta is this angle, inverse cos 3/5. If I draw up a triangle, inverse cos 3/5, opposite side will be 4. And now I can just go 2 sine theta cos theta and read off my triangle. So 2 4/5, 3/5, 24 25ths. Inverse cos of 2 cos pi on 3. We don't have a double angle result because this is not a double angle. This is 2 times the cosine of pi on 3. However, we happen to know what the cosine of pi on 3 is. It is correct to say the ratio is 1/2. 2 times a half is 1. Inverse cos of 1, 0. Inverse sine 2/3 is an angle. Inverse cos of 1/4 is an angle. The mistake made here is assuming they're in the same triangle. They're not. We're talking about two different things. So, will that alpha be sine 2/3? Inverse sine 2/3? Beta. And of course, we're now coming up to the fun part. Because it's tan plus tan on 1 minus...
Tan.
Exactly.
Tim Tam.
Not Tim Tam. Tan. Sum in your ratios and we get our answer. We'll do 1B.